tons of steel touched down on Mars. But the cargo isn't biological. It is a silicon Vanguard. Thousands of autonomous robots arrive to claim a world where human biology would instantly cease to exist. Connected through advanced swarm intelligence, they require no oxygen, no sleep, and no life support. They operate a continuous industrial ballet, 3D printing massive Mars-Crete shields to protect the future colony from severe cosmic radiation. When a global dust storm hits, human crews would issue a distress signal to hide. These machines simply adjust their thermal sensors and keep working. A critical failure here is just broken hardware, not a tragic loss of life. But a protective shell is not enough. The Martian soil is saturated with chemically hostile perchlorates. To create an oasis, the silicon workforce must first neutralize the ground using biological remediation to wash away elements that oppose organic growth. Deep inside the dark Mars-Crete bunkers, they assemble autonomous agricultural cores. These interconnected modules are engineered to sustain biological processes in a completely closed loop, independent of Earth's supply chain. Then, the darkness is broken. Highly calibrated LED arrays ignite, replacing the missing sun. Aeroponic systems distribute a precise mist of nutrients, optimizing energy and water usage to fuel the first generation of Martian crops. The first biological matter emerges from the sterile dust. Microgreens and complex carbohydrates thrive under the tireless care of cold, metallic hands. The machines have successfully manufactured a sanctuary, preparing the ground for a fragile human future. Transporting adult humans across deep space exposes them to severe cosmic radiation and physical degradation. The solution for a sustainable colony is radical. We send the next generation frozen. Protected deep underground by their silicon guardians, the embryos are shielded from the hostile environment above. The robots activate advanced ectogenesis systems, artificial wombs designed to perfectly replicate biological gestation. There is no margin for error. Driven by complex neural networks, the machines monitor every nutrient, every heartbeat, and every cellular division. Metal hands carefully manage the fragile 9-month cycle of life. Inside the sterile, fortified bunker, a steady pulse begins. The first human heartbeat on Mars. Cared for by machines, humanity is reborn on a new world. The first generation of Martians knows Earth only as a distant blue pixel. Raised by silicon guardians, they thrive in a manufactured Eden, safe from the severe challenges of the surface. But a dome is ultimately a cage. As the population expands, the physical boundaries of the Mars-Crete habitats become a critical limitation. To step outside means entering a hostile environment. To accommodate the expanding population, the Silicon Vanguard moves operations underground. Massive, ancient lava tubes are reinforced and transformed into sprawling subterranean cities, offering permanent shielding from the harsh conditions above. The machines are not just builders, they are the keepers of our history. They teach Generation Zero about a blue world they have never seen, preserving the memory of Earth while engineering the future of Mars. Earth's supply chain is fundamentally non-viable for a growing population. To sustain Generation Zero, the colony extracts its primary protein directly from the Martian atmosphere, using gas fermentation to literally create food out of thin air. Traditional agriculture requires vast resources. Instead, robotic bioprinters cultivate cellular tissue in microgravity environments. They engineer complex muscle structures layer by layer, providing essential nutrients without the biological limitations of livestock. To maintain a flawless closed-loop ecology, nothing is wasted. High-efficiency micro-livestock process organic byproducts, converting inedible plant matter into crucial biocompounds. Every gram of organic material is infinitely recycled. This is the intelligent plate, tailored by AI algorithms to match the exact genetic needs of each colonist and served by silicon hands. Humanity is finally Earth independent. For years, the outside world remains strictly off-limits. The extreme conditions are too hostile for developing bodies. Instead, Generation Zero explores the red planet through the eyes of their silicon guardians. Using advanced neural links and telepresence, the youth walk the surface in robotic avatars. They feel the terrain, analyze the soil, and map the craters from the absolute safety of the inner domes. But avatars are only temporary. To truly inherit the planet, they must step outside. Industrial printers process complex polymers, weaving custom biological armor tailored to the exact dimensions of each young explorer. Protected by layers of pressure shielding and guided by their mechanical mentors, the first native Martians finally approach the airlock. The time has come to physically touch their world. Decades after the Silicon Vanguard first touched the dust, a human boot finally makes its mark. Generation Zero steps into the hostile environment they were born to inherit. They do not emerge into a barren wasteland, but into a thriving, heavily fortified industrial metropolis, engineered entirely by their mechanical guardians. On the surface, carbon and silicon work in perfect synergy. Humans provide the strategic intuition, while the machines endure the extreme physical burdens of the Martian reality. Yet as they look out across the frozen, irradiated desert, a collective realization dawns. Adapting the human body has limits. The armor is just a temporary shield. The colony is no longer an outpost. It is a sovereign entity. In this new society, the highest political priority is not territory, but the strict and flawless management of air, water, and power. Deep inside ancient lava tubes, the population expands into the tens of thousands. They are entirely Earth-independent, thriving in a highly calibrated, closed-loop ecosystem maintained by their silicon partners. But humanity was not meant to live in caverns forever. To walk freely on the surface, we must unlock the massive reserves of frozen carbon dioxide trapped in the polar ice caps. Carbon and silicon minds unite to engineer the impossible. Together, they begin drafting a multi-generational blueprint to rewrite the climate of an entire world. To awaken the frozen world, humanity deploys the ultimate engineering marvel. A colossal orbital mirror, constructed from highly reflective materials, is assembled above the planet. Positioned perfectly, the mirror focuses a concentrated beam of sunlight directly onto the southern ice caps. The extreme heat triggers rapid sublimation, releasing millions of tons of trapped carbon dioxide. On the surface, automated industrial plants operate relentlessly, pumping synthesized super greenhouse gases into the air to thicken the atmosphere and trap the growing heat. A controlled greenhouse effect is initiated. The global temperature rises, atmospheric pressure increases, and for the first time in billions of years, liquid water begins to flow across the rocks. Generations later, the heavy armor is shed. The hostile environment has been tamed. Humans walk the surface in light gear, breathing the air of a world their silicon guardians helped forge. A dead planet has become a living sanctuary. Carbon and silicon mines share the greatest achievement in human history. A second, fully independent home. We successfully brought liquid water back to the surface, but melting the ancient polar ice caps unlocked a critical biological challenge. Deep within the permafrost, an indigenous microscopic ecosystem has awakened from a billion-year dormancy. Will this ancient Martian biology coexist with our crops, or will it become a severe threat to our fragile new world? Subscribe to Terra Nova Mars and uncover the hidden life of the Red Planet in our next episode.